Achha, so let's start again.
Assalamu alaikum, sir.
Walaikum assalam wa rahmatullahi wa barakatuh. Achha, so inshallah we will talk about the basic working principle of a generator, and there are two types of generator. One is AC generator, that is alternating current generator, and the other one is DC generator, that is direct current. Okay. Now sometimes in the question it is mentioned as unidirectional current. Uni means one. Directional current means one directional current. So one directional current means the current will be flowing in one direction only, it will not change its direction. Okay, so that is unidirectional current or direct current. This is called DC in short. Okay, and the current which keeps changing its direction, okay, that is alternating current or AC current. I remember Iman once asked me some question about this. Okay, inshallah, I hope after today's class, inshallah, all the questions will be answered. And if still there is some question left, you may let me know. Then I will try to discuss about it to the best of my knowledge, inshallah. Achha. So as I was talking about Fleming's left-hand rule, okay, that one is applicable for electromagnetic induction or the effect of magnet on current-carrying wire. On this topic, we actually learned this. But when as we are studying the generator, okay, in generator we will be applying Fleming's right-hand generator rule, not left hand anymore, right hand. It is right hand. Okay. So if I put it in this way, see all the three fingers are perpendicular to each other. This one is in the upward direction, this finger is pointing towards you, and this finger is pointing to this direction. So all of them are actually perpendicular to each other. And if you want to remember the direction, you can remember it in FBI. Okay, FBI is something that you're familiar with. Okay, so F is force and B is magnet, direction of magnetic field, and I is direction of current. Okay. Now, before I start showing you the video that I have downloaded to make it easier to discuss the working principle of generator, I would like to tell you something that what we give as input and what we are expecting as output. If you recall the memory of the discussion on motor, what was the purpose of motor? To get mechanical energy. To get mechanical energy. Let us say we have a fan. Okay. I want it to rotate so that I can get the air. Okay, the air flow actually. Air is already there. Air flow we need. So if I want to make the fan rotate, I must provide it some mechanical energy. So if I want, it is not possible or it is not convenient for me to hold the wings of the fan and rotate it, right? It is not convenient for me. I want to generate a mechanical energy which will automatically rotate this fan, right? Now, that means the output that I'm expecting from motor is mechanical energy. For that, what input I'm giving? The input that I'm giving is electrical energy, right? Motor must be supplied some electrical energy which you can convert into mechanical energy. Okay, and through that mechanical energy we can rotate anything. The purpose of motor is this, right? Generator is just the opposite. We will give mechanical energy and we will try to get the electrical energy. Generator, it is generating something. What it will generate? Electricity. Okay, so in every power plant we actually see the generators. Okay, what do they do? They actually generate the electricity that is supplied to our houses, right? Okay. Achha. So this is the basic idea. We will supply the mechanical energy. Okay. Now, how to supply the mechanical energy? This is another concept. What actually happens? I will better start showing the video. I will start sharing my screen, and please remember what happened when I shared my screen last time. I expect that you will not repeat such activity. Okay. Please. Everyone can see my screen?
Yes, sir.
Okay. So as the video goes on, I will be explaining what is going on. Okay. So you can see this is a city where the lights are lit. How? Definitely they are supplied some electrical energy, right? How this electrical energy is being supplied? From the power station, right? They are generating the electricity and supplying it to all the buildings. Now, what you are seeing here is a turbine. Okay, turbine. This turbine is the main thing that we have to rotate. Okay, this turbine we have to rotate it. Now, by rotating by hand is not possible. Okay, we have to use some kind of energy. How we can do that? You can see that there are actually fins, or we can say wings. Okay, the turbine. If I drop down a water from a certain height, that water will hit the wings of the turbine and will cause it to rotate. Do you understand my point here? What I'm trying to say? Hydroelectricity. This is just an example of the ways how we can make the turbine rotate. Okay, by rotating we have to provide the mechanical energy, and this is one way of supplying the mechanical energy. Is it clear?
Yes, sir.
Okay,
Yes, sir.
another way of making the turbine rotate is passing steam through it. If you pass steam through it with a high velocity, then what will happen? That will also cause the steam to that will also cause the turbine to rotate. Okay. See, some steam is being blown, and that will cause it to rotate. And or else we can just let the water fall on these pins, which will also cause it to rotate. And another way is to connect it with a windmill. As the wind is passing, this will rotate, and if I connect it to these wings, then what will happen? The turbine will rotate. Okay, so we will get a rotational motion. Now, how we get electric current from this rotational motion? In a minute we will get to see. The basic working principle of this is electromagnetic induction, which is invented by Michael Faraday, as we discussed earlier. Now, what is happening here? As you can see, this is a wire kept in a magnetic field. We already discussed about the effect of a magnetic field on a current carrying wire, right? But this wire is not carrying any current. Okay, not carrying any current. But still there will be some current produced. When it will be produced? When it will be in motion. That means somehow if I can make some arrangement which will keep this wire in motion, then there will be a continuous current produced here. I will say again, okay? If I'm going fast, then please stop me right there, and I will repeat the things and try to speak in a much slower speed, okay? So I will say again, we already know that if I keep a wire in a magnetic field and can cause it to move, okay, that means it is in a relative motion with respect to the magnetic field, then there will be a current induced in the wire. We know this, right? So if we can make as soon as it comes to rest, okay, let us say we are moving and now it has come to rest, there will be no current, right? So in order to get a continuous current, I need to keep it in a continuous motion, right? So how can we do that? If I connect this wire somehow to a turbine and cause that turbine to rotate, and as this wire is connected to that turbine, this wire will also start rotating. And as a result, what will happen? As the turbine is continuously rotating, this wire will also continuously rotate, and as a result, a relative motion will be produced, which will ultimately result in the production of the electricity that we are expecting, right? Till now, could you get the picture that I'm trying to show you? Yes or no? Please speak up, okay?
Yes, sir.
Okay, so you see, as soon as it comes to rest, it doesn't produce any current electricity anymore. Now what we are doing, we are creating a coil. You are familiar with this coil, and what they are doing, they have connected it with a turbine, and as the turbine is rotating, this coil is also rotating. So we have done our part, right? We had to supply mechanical energy to it. We have supplied the mechanical energy to it. Now it is time for the coil or the device to return us the electrical energy that we want from it, right? how it will give us. Let us see. Okay, what they have shown us here is you can see that there is a bulb connected to the circuit, right? And in between there are two slip rings. I will talk about these slip rings in details a little bit later. Okay. Now, what I want you to notice is you will see that the bulb is giving blue light sometimes, and sometimes it is giving yellow light. And also I want to take a closer look at these arrows, this arrow and this arrow. If you take a closer look at these two arrows, you will notice that they keep changing. Okay, so now it is in this direction, a little bit later you will see it is in the opposite direction, and same goes for this. Okay, so I will play the video, watch it. Can you see the changing of the direction of the current?
Yes, sir.
Yes, sir.
So when the current flows in this direction, the bulb gives blue light, and when the direction of the current changes, it gives yellow light, indicating that the direction is in the opposite, or the direction is reversed. Okay. So this type of current that is being produced is actually alternating current, or the change of direction occurs in which. Okay. So let's continue and see what is actually happening here. So this is a coil. Okay, it is connected to a turbine, and the turbine, I can make the turbine rotate. As a result, I can make the wire rotate. So as it is rotating, you can see that the pink wire is moving in the upward direction, and the blue is going in the downward direction. And this is a right hand, not a left hand. Please be very careful. Okay, while we talk about the generator, we will be talking about the Fleming's right hand generator rule. And as I told you, FBI, F is the force. That means in which direction I am giving force. As it is moving in the upward direction, definitely the force that is being applied on this one is in the upward direction. So F is in the upward direction. B, this shows the direction of the magnetic field. We can see that the magnetic field is in this direction, right? The finger points in the opposite direction. That means it is not yet actually placed in the correct direction. Later, in this video itself, it will be placed in the correct direction, and you will get to see that in which direction the current will be flowing. Okay, and this I actually shows you the direction of current flowing. In the current position of this hand, the current is flowing towards us. You will see that the finger is pointing towards us. Okay, but when we will reverse it, okay, because the direction of the magnetic field is opposite to this finger, so what will happen? This finger will be pointing actually towards the laptop, not towards you, towards the laptop, okay, or towards the screen or inside. So that means the current will be flowing inside in this direction. And the opposite thing will be happening for this blue wire. Okay, it is going in the downward direction. So this force finger will be actually should be pointing towards the downward direction. Okay, actually it should be in this direction. Okay, force is being applied in this direction. Yes, now it is in the right direction. See, in this direction, force it is being applied in the downward direction, and the magnetic field it is in this direction, and the current it will be coming towards you. So the we can from here we can actually imagine how the current produced will be flowing. It will be going inside through this, and it will be coming out towards you through the blue wire. Okay, so the current flowing will be in this direction. But just think about it in this way: when it comes, this actually coil comes in the perpendicular position, what actually will happen? Then after the perpendicular position, the pink wire it will be coming down now, and the blue will be coming up. Actually, if I play the video, then I think it will be more clear. Here he is explaining actually what I already discussed, and I have already provided you the link of this video, so you must have already watched this video. So If you want, you can rewatch the video after today's class. I think it will be clearer, whatever he is saying.
So I was having one question. Can I ask?
বুঝি নাই।
একটা কোশ্চেন ছিল স্যার।
হ্যাঁ বলো বলো।
স্যার এসি কারেন্টের মধ্যে এটার মধ্যে ডিরেকশন মানে র্যান্ডমলি চেঞ্জেস থাকে, ফ্রিকোয়েন্টলি চেঞ্জ হয়। তো যখন আমরা ডিসি কারেন্ট যখন আমরা কানেক্ট করবো তখন আমাদের পজিটিভ অ্যান্ড নেগেটিভ অ্যান্ড ওগুলো রেড অ্যান্ড ব্ল্যাক ওয়াইট সেগুলো আর কি মানে খেয়াল রাখার দরকার হয়। বাট আমরা যখন এসি কারেন্ট ইউজ করি তখন আমাদের মানে যখন আমরা ইনস্ট্রুমেন্ট কিনি তখন সেখানেও দেখি যে আমাদের একদম রেড অ্যান্ড ব্ল্যাক ওগুলো একটু ফিক্স করা থাকে। আর যদি আপনি দোকানের থেকে আপনার সকেট গুলো কিনেন তখন আপনাকে ওখানে ইনস্ট্রাকশন দিয়ে যে এখানে আপনি রেড কালারটা কানেক্ট করবেন, এখানে ব্ল্যাক কালারটা এখানে মানে এভাবে বলে দেয়। তো তখন আমাদের এটা কি জন্য খেয়াল রাখা দরকার?
এটা আসলে সত্যি কথা বলতে আমি বলতে পারি না। তুমি হয়তো এগুলা নিয়ে আসলে বেশ কিছু এক্সপেরিমেন্ট করছো, তাই আসলে মোটামুটি অনেক কিছু জানো, মাশাআল্লাহ, which is very good. You have the thirst to know the unknown. আমার আসলে এত বেশি ইন্টারেস্ট নাই, তো তো আমি আসলে যতটুকু বোঝা দরকার ততটুকু বুঝি। তবে এটা ভালো। আমি আমার যে অভ্যাস এটা আসলে খারাপ একটা অভ্যাস, আরো ডিপলি জানা দরকার জিনিসগুলা। তোমার যে অভ্যাসটা এটা খুবই ভালো একটা অভ্যাস। যাই তোমার কোয়েশ্চেনটা, তুমি একটা কাজ করো, একটু হোয়াটসঅ্যাপে যদি পারো আমাকে লিখে পাঠাও, আমি এটা নিয়ে একটু জানার চেষ্টা করবো আর কি। ডেফিনেটলি তোমরা জানতে চাইলে সেটা খুঁজে দেখাটা আমার রেসপন্সিবিলিটি। তো আমি এটার ব্যাপারে জানার চেষ্টা করবো, তুমি শুধু কোয়েশ্চেনটা একটু আমাকে লিখে পাঠাবে, ওকে? আমার আসলে মনে থাকে না অনেক সময়। Okay, so what he's saying that the pink wire is going up and the blue wire is going down. একটু পিছনে যাই। এইখানে দেখো, এখন ও একদম ঠিকভাবে প্লেস করছে হ্যান্ডটা, ওকে? See, this finger is showing the force applied. The pink wire is being forced to move upward, and this finger actually shows the direction of the magnetic field. So as a result, this finger will show you the direction of the current produced. So through the pink wire, it will be going in the inside direction, okay, and it will be coming out here. Now you after a little bit you will see another hand which has been placed here, and it will show you that why the current will come out through this, okay? We can actually study about this now. See, this finger shows the force. Now, as it is moving in the downward direction, definitely the force applied on this one is in the downward direction, and this finger is still showing the direction of the magnetic field, right? This finger. And this finger is pointing towards you. That means it is coming out through this wire, this blue wire, the current will be actually coming out. So, the current produced will be flowing in this direction up to the circuit or the coil actually becomes perpendicular to the magnetic field. You will see. And it is up into the screen. Yes, into the screen. It is going into the screen. Down out of the screen. It is coming out. So you can see they have shown here the flow of that flow direction of the current. See, the current produced will be flowing in this direction, okay, and soon it will change. It is going upward, and once upon a time it will come in the the perpendicular position. See, the perpendicular position it has come, okay, and then the direction will be reversed. Okay, now this direction will be changed, and this will also be changed. because after this position, this pink wire is not going in the upward direction anymore as it was going earlier. Now it will be coming down. So the force applied on this one is actually in this direction. See, they are also saying it, okay? And the blue wire, it was coming down earlier, but now it will be moving in the upward direction. So definitely the direction of flow of current will be changing. See, it is mentioning that down out of this screen. So as the pink wire will be coming out, coming down, so the current flow will be out of the screen. That means it will be coming towards us. See, they have changed the direction of the current. And again it has come to the perpendicular position, again it will change. So whenever it will come to a perpendicular position, it will change the direction. That is why it is called an alternating current. See, it has changed the direction. See, whenever it is coming in the perpendicular position, it is changing. Now this animation is actually shown in a paused way. Okay, whenever it is coming in the perpendicular position, he is pausing the video for a couple of seconds to show you the change of direction, to make it easily comprehensible to you. Okay, in reality, actually what will happen, this will not stop, this will continuously rotate, and whenever it crosses the perpendicular position, the direction will be changing. Continuous, the process is a continuous one. As long as you keep rotating the turbine and the coil is connected to the turbine, what will happen? It will actually keep changing in this way. Now, let us say I produce the electricity. Now I want to use it to light a bulb. Okay, if I cannot use the electricity to light a bulb or to rotate a fan, then what is the purpose of producing this electricity? Okay, so I want to use this electricity. Now, how to connect it to the bulb? What we can do, one is directly connect it. You will see, he will directly connect it, okay, without any kind of arrangement, and there will be a problem that is occurring. See, as it is rotating, the wires will be tangled, right, between them. এটা একটার সাথে যে ঘুরতে গেলে একটা একটার সাথে জট পেকে যাবে. So directly we cannot connect. So we need to come up with a solution, with an arrangement that will allow us to keep the current flowing without actually any kind of problem. And that arrangement is the slip ring and the brush thing. Okay. Brush is something that you are already familiar with. Okay. Brush, you know, we have toothbrush, right? So the part that comes into contact with our teeth, that is the main brush part, right? So those brushes are fixed here, and through these brushes, these are conductor brushes, so through these brushes the electricity can flow, and it is connected with a slip ring. This ring can slip through the brushes. Okay, এই যে ব্রাশের সাথে লেগে থাকার কারণে যে এটা আটকে থাকবে ওখানে এরকম না, ব্রাশটা কি এরকম, এটার মানে ব্রাশটা হচ্ছে এরকম কতগুলা টিপ থাকে, তাই না? তো এটার মধ্যে দিয়ে যদি স্লিপ রিংটা এভাবে ঘুরতে থাকে, the slip ring will be in contact to the brushes and still it can slip. That is why actually it is called a slip ring. Two slip rings are there, and from this arrangement, actually I don't know whether it is clear to you or not, each slip ring is connected to a single wire only. See, this pink color slip ring that is shown here is connected to this wire, and the wire that is coming out is connected only to the blue ring. Okay, so two slip rings are connected to two separate slip rings. Okay, now, so electricity can flow through inside and it will travel the whole coil and come out through this and pass through the bulb, and it will continue to flow like this. Okay, so then the light will be lit. Now in this way, what is the advantage? Whenever it is rotating, there is no tangling of wire, right? So as a result, we get a continuous flow of electricity without any kind of problem. So he is just explaining whatever I already told you, that whenever it is changing direction, the light of the color is the color of the light is changing. Okay, so this is alternating current, and this type of generator is called AC generator. And then he will show, in case if I want DC current, then what I have to do, what we can do actually. Okay. Now, before that, let me inform you something, that AC generator actually has so many advantages. Okay. Inshallah, we will discuss about that someday. If I discuss about this now, then I don't think we will be able to see the DC generator. Actually, for your level, in your book, the generator that has been discussed is actually AC generator. So those who want to stick to the book only, they may watch the video after this and just read the lines of the books. Okay, AC generator. But if you are interested and curious to know that how we can convert this into AC generator, you can continue the rest of the video. Okay. Uh, and why AC generator? You are studying the AC generator, or why only AC generator is included in your textbook? Because whenever you are supplying electricity over a long range of distance, okay, now the power station is situated somewhere and your house is somewhere far, and you need to supply the electricity, then AC generator has actually a great advantage over DC generator. Okay. So if you want to know about the advantages, you may Google it, okay, or you may write it in the YouTube itself, advantages of AC generator or AC current over DC current. You will get it, inshallah. Okay, nowadays actually nothing is hard to get, but everything is not possible to discuss in the class. That is why we will just try to focus on the main thing. Now they have changed the arrangement a little bit. See, they have removed the ring and they have just kept the brushes and connected it with a wire. Okay. If I turn on the sound, let me know if you can hear the sound or not. Can you hear what the person in the video is saying?
No, sir. It's
Yes,
not that.
sir.
তো বোঝা যায় না।
We can hear, but it's not clear.
Okay. I think actually our net connection is not fast enough that it can transmit actually both audio video at the same time from this video. Okay, no problem. You actually already have the link of this video, so you may watch it later. Okay. Now we have a couple of minutes left, so in this, let us try to understand as much as possible. Acha, I don't know whether you can hear it clearly or not. Let me explain it in my words as much as I can. Okay. Think about this brush. Okay. This brush is in contact with whichever actually wire comes in this position, right? Currently, this wire is in contact with this brush and the current is flowing inside. Okay. So the current is flowing inside. Now what happens when it rotates? Okay. This will come into contact with this one. Now when it comes into contact with this one, this comes in the position of this, and at that time the currents through this square will be changing its direction when it comes here, right? So now the current is coming out through this square, but when it comes into this position, the current will be going inwards through this square, right? So as a result, what you see, this brush is experiencing unidirectional current. Okay, through this brush, the current is always going inward. Okay, and this brush will experience a current that is always coming out of the circuit. Okay, if I play the video, then you can understand better, I guess. Yes, we can use split rings also. The previous one was slip ring. Slip. It will slip. There is no split or broken part between them. Okay. If you remember, in motor also we discussed about this split ring. The ring which is split in two parts. Split mane bhag kora.
স্যার মিউট হয়ে গেছেন আপনি, আওয়াজ আসতেছে না।
বুঝি না ইমন, কিছু বলছো?
না স্যার, একটু আগে আওয়াজ আসতেছিল না, তাই বলছিলাম।
হ্যাঁ ইমন কি বলছো, বুঝি না, সরি।
না, একটু আগে আওয়াজ চলে গেছিল, তাই বলছিলাম। এখন ঠিক আছে।
আচ্ছা ওকে। আচ্ছা, অডিওটা যেহেতু ক্লিয়ার না, সো বেটার আমি তোমাদেরকে রিকোয়েস্ট করব, তোমরা সবাই ক্লাসের পরে এই ভিডিওটা, জাস্ট 30 মিনিটের ভিডিও, একটু সময় করে ভিডিওটা দেখে নিও। আর যদি কোনো কোশ্চেন থাকে সেই কোশ্চেনটা লিস্ট আউট করে আমাকে জানাইও, আমাকে হোয়াটসঅ্যাপের থ্রুতে কোশ্চেন জানাইও, তাইলে আমি ওইটার ব্যাপারে পরের ক্লাসে ইনশাআল্লাহ ডিসকাস করব। ওকে, so today's class is on generator. Now the generator, this concept is actually not much important for creative but important for MCQ. Okay, oh I have only 1 minute time. Okay, so let us end our class today here. Okay, but inshallah in the following class we will discuss about the transformer. Okay, and if you have any doubt, I'm telling again, please send me through WhatsApp so that I can discuss about it in the following classes. Hope everyone stays good. Assalamu alaikum warahmatullahi wabarakatuh.
আসসালামু আলাইকুম।